So in this video, we're talking about the relationship between Gibbs free energy and equilibrium. So if you remember from a previous slide, we said that when a system's at equilibrium, the free energy is zero. So you've got a system where both the forward and the reverse reaction are going simultaneously, and so whatever energy is generated in one direction is consumed in the other, and so the change in Gibbs free energy winds up being zero. So there has to be a relationship somehow between Gibbs free energy and the equilibrium constant. And that relationship can be represented by the following equation. Delta G naught is equal to negative RT ln of K. So R is the gas constant, T is temperature, and obviously K is the equilibrium constant. So here is an equation that lets us relate equilibrium and thermodynamics. So if you remember, delta G naught is equal to negative RNT ln of K. And then if you're that's at standard conditions. If you're at non-standard conditions, we have this second equation. So delta G at the non-standard conditions is equal to delta G naught plus RT ln of Q. So remember, we're not at standard. Delta G is not zero. And so the equilibrium constant is not K. The equilibrium constant is equal to the equilibrium quotient. So note that, okay, not sure why timing-wise it went that way, but okay. So under standard conditions, we use delta G naught. Under non-standard conditions, we use delta G. So here's the relationship between those two. And remember that delta G at equilibrium is equal to zero. And so if delta G is equal to zero, we've got delta G equals negative RT ln of K. So that's how we can get back and forth between the two, or that's how the two are related. So here's an example. We want to know what the delta G naught of this reaction is at 298 degrees. So we can figure out that by using the sum of the products minus the sum of the reactants. You wind up with delta G naught in this case is 29.6 kilojoules. Okay, now what's delta G? So we have delta G naught, but what's delta G under these conditions? So we've got to take that delta G naught, figure out delta G and the equilibrium constant, or the equilibrium quotient, using this equation. So Q is equal to, since we have pressures, we're doing the partial pressure one, the pressure of pH 3 to the 4th. So this is just equilibrium expression here that I'm solving for. I'm solving for the quotient. P of H2 to the 6th times P to the 4th. I'm not sure why I have an X there. That kind of looks funny. And so we wind up with a Q value of 1.79 times 10 to the negative 6th, which means delta G is going to be negative 9.3 kilojoules per mole. So at 298, delta G naught has a certain value, but delta G, because we're not at standard pressure conditions, delta G is not going to be equal to zero. Okay, and that's the end of the slide. Swear I had another one. All right, so you've got the relationship. That major equation that we had is what lets you relate delta G to delta G naught.